Okay, so welcome to the Computer Science OCR class, and we are on the topic of algorithm. We have started section 2 of OCR Computer Science syllabus, and we learned about abstraction, we learned about the structure diagram, and now we are working on algorithm building blocks. What do you mean by building blocks? It means that you cannot make an algorithm, a perfect algorithm, without these things: sequence, selection, and iteration. So what is sequence? I think you know sequence means the thing one after another. So
Yes.
called a series of steps that are to be completed one by one. Like I teach you yesterday that there's a sequence in a program. Like these are the sequence of programming. Let me draw a chart for you again. So you can see that like this. So this is the sequence of a program. So in the first thing, in the first step, we input the data. In the second step, we process the data. And finally, we output the data, isn't it? So this is a perfect sequence of programming, right? So in this way, we are going to write an algorithm where the steps of programming must be in a sequence. Isn't it, Adam?
Yeah.
Okay. Selection. Steps that only occur if a certain condition is met. What do you mean by selection? Like selection means to choose something. Choose something. How? Like if I'm going to write a snippet here, if age is greater than 18, then output you can drive. Else output try next year. Okay, so this is a snippet here. In this snippet, you can see there is a condition of if. So if the age of a person is greater than 18, so the person can drive. Or else, if he's not greater than 18, then he need to wait for the next year. So in this construct of if collection, if then else, this is an if then else construct, right? If then else, right? If then else, right? We have to choose an option. What is the option in there? Adam, what's an option in there?
If they're 18
Yeah,
or not.
18 or not. So if the person is 18, then he can drive. Else, he need to try next year. So the selection works like this. Listen, I'm going to draw a flowchart for this. Look, this is a condition box. Selection. So one option is for yes, and the other option is for no. So the construct is if age is greater than 18, isn't it? Yes. If
Yes.
it is yes, so he can drive. I'm just writing dr, drive. And if he is not greater than 18, then he need to try next year. I just writing try here. Okay. So right here you can see the both conditions are quite clear. So in this way we are going to use the selection. Is that okay or not okay?
That's okay.
Okay. Now the third step is the iteration. Iteration means repetition. Like if you wanted to repeat anything for a fixed time of numbers or until a given condition is met. Like iteration means loop. Do you know about loops?
Um, yeah, when it keeps asking the question until the criteria.
Yes, perfect. So in our algorithm, if we need to repeat anything, so we use iteration. In algorithm, if we need to give a choice, so we need selection. And in algorithm, if we are going to follow one step after another, that's called sequence. So take out your notebook. You need to write down this sequence. This is for sequence. SEQ. I'm writing SEQ for sequence. This is for selection. It's already written. You need to write down this snippet. After writing this snippet, you need to draw this condition box. Do it now.
Okay.
Now we are going to start that how do we applying our computational thinking to solve or make a program. Like everyone have a kind of computational thinking, but the basic thing, how do you apply it? So there are techniques. What are the techniques? There are four main stages to solve any problem, and different computational thinking techniques can be applied at each one. So there are some four steps, right? Main steps, which we are going to apply. The first step is to analyze the problem. The second step to design the problem. The third step to design the implementation. Like whatever you have designed, you need to implement it. And finally, whatever you have programmed, you need to test that program. Without testing, the program is nothing. So first step is analyze the problem to fully understand it through decomposition and abstraction of the problem. Yesterday we have done decomposition. Do you remember what is it?
It's when you break down a bigger problem into smaller
Perfect.
sub-problems.
And do you know what is abstraction?
Um, oh, that's when you take out only the relevant information? Or, yeah, removing like irrelevant stuff.
Yes, perfect. So once we are going to combine abstraction and decomposition, so we will find our answer. We will find the answer, or we are going to go through the problem, right?
Yeah.
So if you are going to decompose your problem, if you are going to abstract your problem, you are able to design a good program, right?
Okay.
Okay. Next is designing. What is designing?
Design to come up with a solution?
Basically, design means that you are going to design whatever you have conclude from analysis. Like whatever you have conclude from decomposition and abstraction, then you need to design that thing, what you have learned. So design means a solution to the problem using algorithmic thinking and abstraction. Right?
Okay. Yeah.
Like whatever you have learned from analysis, that the program needs decomposition, the breaking down the program, to learn the program, to solve the program in an easy step in abstraction. So these all things need to be conclude on a page, and you are going to design that what you are trying to make, what you are trying to do. That designing is taken from the analysis, connected from the analysis, isn't it?
Yeah.
Okay. Third is implement. What is implementation? Whatever the solution you write, by writing a program based on the algorithms. Like you have done analysis, you have done design, now you're going to write down the program, and that writing the program is called algorithm. So in implementation, you are going to write down the program, and you are going to use some examples used to implement the design phase, analysis phase into the program to show some physical appearance of the program. Likewise, you are going to design a program for a rent-a-car, right? So you analyze the rent-a-car by collecting the information about the cars. Then you are going to design the program by inputting the pictures of that cars. And finally, you want to implement whatever you have right? And once you're done with the implementation, you need to test your program, isn't it? So to test each of the outcome from the initial computational thinking, for example, has each part identified through decomposition worked? Like whatever the program we have done, we need to test the program. We need to test the value. Like let's suppose we have to make a program for sum of two numbers. Sum of two numbers. So for the sum, we have to need two numbers, num1 plus num2. So if I'm done with this program, I need to input the values to check whether my program is going to sum of the things. So I input 3 here, I input 2 here. I run my program. What will be the output? 5.
5, yeah.
So if my output is 5, it means my testing is completed and my program is working perfectly.
Yeah. Yeah.
Write down these steps quickly. Okay, so what is pseudocode? I told you that algorithms means pseudocodes.
Yeah.
Okay, so what is pseudocode? Pseudocode means that you are writing a program with the help of steps like algorithms. So the algorithm is written in pseudocodes. These are the English type words. Okay, now let's suppose we are going to create a program. I told you, what are the steps of programming? Can you tell me?
Um, what you call it? Input,
Yes.
process, output.
Excellent, Adam. Excellent. So in the first step, look what you are doing. You are going to input number 1, input number 2. Now the question is, what is number 1 and number 2? Number 1 and number 2 are both variables. Are both variables.
Variables.
What are variables, Adam?
Um, they hold uh they hold data
They hold data for temporary
that
basis,
can be changed,
for temporary basis or permanent.
but temporary.
Perfect. So number 1, look, I have generated 2 boxes. So the variables are the boxes and empty boxes. In that empty boxes, we are going to input. So if I'm going to input number 1, so you're going to ask for input number 1. So I'm going to write 7 here. Okay, input num2. In num2, I'm going to input the value like 5. Now, can you tell me if num1 is greater than num2, then output yes. Can you tell me about our input, this situation? What will be the answer? Our answer is yes, else no.
Yes.
Why?
Because wait, that is greater than, so because number 1 is greater than number 2, so it's gonna be yes.
Perfect. Okay. So it means that there's a comparison between num1 and num2. So I have put a sign of greater than. So 7 is greater than 5, of course, so it is yes. But if I'm going to write 17 and 51, so what will be the answer now?
No.
Of course. So this is how we are going to use the pseudocodes. So the pseudocode is a way to write algorithms, right? Using code-like statements. But it is not an actual program. Like this is just a recipe. Okay, so this is used to make or plan the algorithm, like how do you make a program. Okay, another program I'm just writing for you, like input num1, input num2, sum is equal to num1 plus num2.
Yeah.
Then friend So can you tell me the value, the answer, if you're going to perform this same function on my algorithm as well? What will be the answer?
Um,
No.
it's the same.
Yes.
Oh no, it will it will plus them together. So
So
um, that's 70, 78.
that's 68,
Oh, 68. Oh, sorry. My
right?
math.
Perfect. So now you need to write down these two pseudocodes, this one and this one. So two pseudocodes are algorithms are there. Okay, do it now. I'm waiting.
Yeah.
Okay. Okay. So now we are going to work on the pseudocodes which are used in our OCR course. So the first algorithm structure based on the variables. So we have already discussed about variables in detail. I think you already know what is variable now. So
Yes.
variables are assigned using the is equal to operator. Yes, like x is a variable and x value is 3. So the is equal to sign is also called assignment operator. What it called? Assignment
Assignment.
operator. So instead of is equal to write assignment, if you are going to make this arrow, so this works as the same as is equal to, right? So
Yes.
if you're writing, listen, if you're writing x is equal to 4, so it means you're assigning 4 to what? To a variable x, isn't it?
Yeah.
A variable is declared at the first time a value is assigned, right? So what is variable in here? Can you tell me again?
X.
X. And what is the value of x?
3.
Oh my God, I'm talking about this.
Oh, 4, 4.
Perfect. So it assumes the data type of the value it is given. So can you tell me the data type of 4? Like, is it integer or a string?
Uh, a integer.
Yes. So the data type is very important. You must know what is the data type. Like data type means if it is an 4, 5, 6, it is an integer. If it is an alphabet, it must be string, right?
Yeah.
Okay. Now variables declared inside a function or procedure are local to that subroutine. Now this is a thing we need to work on. Like variables are, I'm just writing VAR, variable, right? Variables are declared, right? In a specific function or procedure, right? Like if you wanted to make a sum of two numbers, sum is equal to num1 plus num2. So this is a function. Or if you're going to use it in a procedure, or you wanted to repeat the thing in your program, so the procedure will work. So variables can be assigned with the functions or with the procedure depending upon the need of the person. Like if person is using any function, or if person is using any procedure, app for function, p for procedure. So variables in the main program can be made global with the keyword global. Okay, now I'm going to tell you what is the difference. Global is a variable which is used anywhere in the program, I think. Yeah, like, and local variables, no, locals are used anywhere in the program. Local variables. Local variables are the variables which used in some specific part of the program. Like user ID is a variable, and user ID is assigned as 123. So user ID is not going to be used in the whole program again and again. So that type of variable is a global, which is used not in the whole program. But if any variable is using throughout the program, that variable is known as local. Are you getting my point?
Yes.
What is local variable? Local
Um,
can be used throughout the program.
yeah.
And what about global?
It cannot use at the beginning of
Wait a minute. I'm going to give you the definition. Wait. Just taken out from just a second.
Okay, done.
Do you understand about local and global variable?
Yes.
Okay. Now the next topic is casting.